Now in this video, we are going to see how we measure length, mass and time. For normal day-to-day measurements, we use a meter scale. With a meter scale, we can measure something as small as a millimeter and as big as 100 meters. How do you measure small things? We can use a vernier caliper. Vernier caliper we can measure up to 0.1 millimeter. Or we can use a screw gauge. Screw gauge we can measure up to 0.01 millimeter. Suppose we want to measure smaller things. Then we have to use a microscope. How do you measure the radius of a nucleus? That is very, very small. For that we use electron microscope. In electron microscope we use the wave nature of electron. So this way we can measure small things. Suppose we want to measure big lengths, distance to a planet, to a star. For that we use the parallax method. If we remember, when we have got an angle theta, this theta in radians is length up of arc by radius. So theta in radians is length of arc s by radius. Now suppose we are looking at a planet or a star that is very, very far away, and we look at it from 2 points on the Earth's surface. One point is at A, other at B. Now because the star or planet is very far away, this angle theta will be small. This theta is called parallax angle or parallactic angle. Now we can take this almost as an arc, because the angle is small, AB can be taken as an arc. The distance AB is called B. B is for basis. We want to find the distance D, the distance of the star or planet from the Earth. Now if we take this almost as an arc, theta in radians will be B upon D. Now we can easily find D. D will be B upon theta. So now we know the distance to the star or planet. The next thing, we want to find the diameter of the planet or star. How do we do that? Now once we do know this distance D, then we can look at the angle theta subtended by that star or planet, or it may be sun also, moon also. So we get this angle theta. We know this D now. We have to find this small d. Again using same logic, theta in radians will be D upon D. So this small d will be D into theta in radians. Parallax method is as simple as that. Just using the fact that theta is S upon R. S is length of arc and R is radius. This straight line can be taken almost as an arc, and based on that we get the distance D to a star or the diameter small d of a planet, star, sun, moon, etc. Now how do you measure mass? For measuring mass, we have got weighing scale. That is for our day-to-day measurements. For measuring small mass, we use mass spectrograph. How to measure large masses? How to find out the mass of sun, stars, planets? For this, we use Newton's law of gravitation. Newton's law of gravitation tells us the force between any two particles is given by gm1 m2 by r square. So using this equation, we can find the masses of heavenly bodies. How to measure time? For time we have got a normal clock. For accurate measurements we use a cesium clock. At the National Physical Laboratory in New Delhi, we have got a standard clocks, a cesium based clocks that keeps time, and that's how the Indian Standard Time is kept track of. So time is measured using a clock.